How to build an FPV drone. Welcome to Drone Recipe. Thank you for tuning in. My name is Peter and I am the host for the show. Today we're going to be doing a 5-inch quadcopter build. Now this scratch build is going to be made using parts that I have laying around. Some of the parts you may think are a little bit outdated, maybe, but I'm just using what I have. But so there's flexibility if you want to choose other stuff. But the most important thing is to have ESCs and a flight controller that are able to handle D-shot. And with that, you don't have to calibrate your ESC, so it's very simple for you to do. The Quadcopter parts list, as you can see here, is pretty broad. Doesn't give you many specifics other than the ESC, the motors, the flight controller, but other than that, everything is pretty much open. Okay, and here's the JST plug from the DYS 4-in-1 ESC. I have 3 sets of power wires starting from the top that are twisted. The first set is 12 volts, the second is 5 volt, the third is VBAT, which just provides the current of the battery, and the next 4 wires, starting with yellow, are your motor wires, so yellow 1, blue 2, green 3, white 4. Now most 4-in-1 ECs come fixed in terms of motor configuration. As you can see on this one, motor 3 is where motor 1 is in Betaflight motor configuration. And on top, meaning the motor right above, is motor number 1. And that would go, so that pin, motor number 1 pin from the ESC, would go into motor pin number 2 in the flight controller. Sorry about the camera, guys. And that's motor number 2 on the ESC, which would be motor 4 on Betaflight, clean flight. And then the bottom left, which is motor 4. So that would go into motor 3. Here's an illustration right here with the flight controller on, just with the motor leads. And here's another visual aid. I'm not sure why I put the arrow there. Okay, first thing I'm going to do is I'm going to desolder this because I think it's a little bit too long. Sometimes you just get it per connection, or just based on the solder. So I'm going to re-tin that a little bit. Now I just want to show you how I mount the ESC and also for the flight controller. I use 4 nylon bolts. And then I secure the bolts with some nylon nuts at the very end, so that keeps it nice and true and level. Just use some DIY earbuds, remove the inner piece. I was left with the stub, and that's what I used. And that just sits right on top of the nylon bolt nut through the nylon bolt, and you get this kind of vibration dampening effect here. It's nice and squishy, but not too squishy. The way they give it to you, which is better, longer than shorter, and they have that a very good XTC connector. Venom batteries use that too, and it's 14 gauge wire, about 195, about 100 millimeter. So I'm going to take about. I want it to be about like that, I guess, so I can go right underneath. I don't want it too short, and if it gets into a crash, you want to have a little bit of leeway just in case. So I think figure it out about there. Should be good. Sometimes I like to curve mine just by making one wire longer than the other, so you get a nicer fit. I think that's of course my preference. Yeah, so take these off. I like to use these save me a lot of time and trouble. You can do more than one at a time, but just to get this right, I'm going to do one, and that should be good enough. What you want is to have it kind of flush with the edge of the board, but not, protruding so much where it makes contact or shorts. You don't want it pulled back enough where you have it exposed. So basically just as long or a little bit longer than the actual pad. Damn sponge here. Let's get the wire connector on first. Just a little snip. Make sure you grab that later. Now, one thing I should have done a little bit differently here, just to illustrate, was to ensure that the wire, the one that I'm doing right now, is held a little more closely towards the edge of the board so that it doesn't move. As you can see, I'm kind of a little bit too far away from it, and you want to ensure that you don't move it as to not create any cold solder joints. And this is 60/40 solder. Now you'll see with the red one, I move my finger up a little more closely. Now the wire will get hot, so maybe use some tweezers or some pliers, but don't pinch the wire, and just place it like that. And this should be alright, as long as the bulb doesn't light. Right? There's two filaments in here to pick up low voltage and higher voltage. You got that, everything's good. Now moving on to the quadcopter motors, I'll be using the Emax 2205 2300 kV. Now these are fairly popular, but they're also cheap now, so that's what I'm going to use. Soldered up. Not soldered up, but I have the wires extended because the wires were short. I didn't have to extend the wires for this build. So I went ahead and attached the motors with some blue Loctite. Please don't use red. And I've also trimmed the wires for the motor so that they'll seat into the EAC properly. And I'm going to bend them from the inside towards the out. As you can see, the LiPo lead is a little bit shorter here. Also attached a JST plug for the VTX. I'm just using some rosin core flux.
Okay.
Just to lightly brush the pads.
Just give it a swipe.
I'm just going to speed this up for you so I don't bore you half to death, but I'm just tinning the motor wires so that they're ready to be soldered onto the pads onto the 4-in-1 DYS ESC, D-Shock capable. I'm also going to tin the pads on the ESC and also snip the wires to size so that they fit on the pads perfectly. Alright, I'm going to do the same thing for the for the soldering of the motor wires. Now, as you can tell, this is a different quadcopter. Unfortunately, I lost the footage for the 30 amp, and this one here is very similar. This is the 20 amp DYS 4-in-1 ESC, which is pretty much the same. You get a little more room though in terms of the soldering pads, and as you can see there, I took a nice chunk out of the that JST connector. So just be careful with your iron. And this is how the finished product should look like. And you can see the wires, how I bent it from the inside, just so the wires are not exposed. Okay, now it's time to flash and configure the ESCs. You'll need to go to the Google Play Store and install both BL Heli Configurator and Betaflight if you haven't already done so. You go to the Google Play Store and download the BL Heli Configurator app and connect. Make sure you have your battery plugged in with your smoke stopper and press read setup. That's going to read your current configuration, and you should see 4 ESCs to the right hand side. If you do see 3 or 2, that means you have some kind of it's not reading your ICs. So now usually the causes for the ESC not showing is poor soldering, so you want to check over your soldering joints, otherwise it could be those other 2. Once you have everything figured out, go to the flash screen, pick the latest one, pick the D-Shot, sorry, and press flash. You have to wait for the bars on all 4. The menu to the left hand side, you don't really have to do too much to that. Just make sure your motor timing is on medium. Now, unless you have a DMAG, I wouldn't even get into that because I don't want to confuse you. Just leave that stuff and just make sure you flash, and then also make sure that the numbers here, see how I'm just adjusting that, are the same for all. This only applies to D-Shot in an effective way. So make sure that all the numbers are even, and then you press read or write setup. So you apply those settings to the ESC. Okay, I'm going to be reversing some of the motors and the motor direction drop down. This is where you do that. Make sure you write the setup. And I'm going to motor timing. I'm actually picking medium high because I had higher kV motors, thinking that that's what I needed. But ended up I had to change that back as it was making the motors too warm. Now in startup power, just you can leave it at default or even 0.75. That should be alright. And make sure you press right setup so that the settings take thing, and then disconnect. Once you disconnect, you'll hear the ESC sound up from beginning to end, and that's it for flashing the ESC. Okay, now I'm going to be tinning the motor signal wires from the DYS 4-in-1 ESC so that it can be soldered into the flight controller. Now it's important not to put too much solder, as you want it to be thin enough to get through the pinholes, as I will show you later, because we're going to be soldering through the pinholes. Okay, I'm just going to go over the flight controller real briefly here. This is an F4 flight controller. It weighs 5 grams. The format is 36 millimeters by 36. The holes are 30.5 millimeters to 30.5. It has the MPU 6000 gyro and accelerometer. Has an independent 3.3 volt power supply. The input voltage to power this flight controller is between 5 and 8.4 volts. The target when you flash this on Betaflight will be Revo or CC3D Revolution. It also has a boot button, as you can see. Has LED and black box support. And it's also capable of doing 6 motors, so it can do a hexacopter. And it's supported by Raceflight, Queenflight, and Betaflight. But by default, Betaflight is on this flight controller. This is the S-Bus and I-Bus wiring configuration. Now, if you're still using PPM, all you have to do is move the white wire from S-Bus to the pad above where it says ppm. This is your S-bus diagram. Here's your ppm diagram. And this is what I'm going to be using, so this is the spectrum. Next thing we're going to be doing is flashing the flight controller with the correct firmware and the latest firmware. Make sure to do this initially once you get the flight controller so that, you know, if there's any issue you can return it. You don't want to return it with solder on it. So we need to get into Beta Flight. If you haven't downloaded that, please do so from the Google Play Store. Plug it into the USB port and you should see the COM port on the top right hand change. Press connect. Then on the left menu, the very bottom says CLI, C-L-I. Press that and then type in, like I'm doing, version, and that should tell you the existing version and the firmware that's flashed on the flight controller. As you can see, this one has 3.0, so it definitely needs to be updated. Okay, so now what you want to do is type in dump or dir, either or, and that'll give you the actual kind of blueprint of your flight controller. So what you want to do is copy and paste, but onto Notepad. Do not do it on Microsoft Word or it will not work. And just save it accordingly, whatever name. Just put in as much details as you can. Just makes it easier. Then once you save that, you can flash your flight controller to the latest firmware. But before you can flash your flight controller, you do have to put the flight controller in bootloader mode. And the easiest way is to type in DFU, enter, that'll reboot, and your flight controller will reboot in bootloader mode. And you'll see the DFU on the top right hand corner. And once that's in DFU mode, it's ready to flash. So the next thing we're going to do is press firmware flasher on the left hand side. And at the top, we're going to pick Revo, or sometimes it already automatically populates it for you. And in the second drop down, we're going to pick the version, the latest version. Doesn't always have to be the latest, but usually is. And I'm choosing to, seems like I wasn't sure here, I'm choosing to full chip erase. And we're going to load firmware online. Once it loads, we're just going to press flash firmware. You can see it's erasing. So once it's flashed, you'll hear that sound. And then you can, on a VC port, you can just press connect, which means your USB is separate from all other connections or UARTs. And there you go. Okay, now we want to confirm that we actually flashed the latest firmware, so we go back and type in version again in the CLI menu. And once we press enter, that should give you the latest firmware. This is 3.1.7.